In this lecture, I'll be talking about affinity and anti-affinity in Kubernetes. In a previous demo, I showed you how to use the node selector to make sure pod gets scheduled on specific nodes. This was the example that I was using. It's a deployment, and in the specification, I used a node selector to only schedule the 3 pods that this deployment is going to start only on nodes that have the label hardware equals high spec. So if the node doesn't have this label, the pod will not be scheduled on that node. So you need a node with exactly this label to have this pod scheduled. Affinity and anti-affinity that I'm going to show you in this lecture are similar to what the node selector does. The affinity-anti-affinity feature allows you to do more complex scheduling than the node selector and also works on pods. So not only for nodes, also for pods. The language that you can use is more expressive. You can create rules that are not hard requirements, but rather a preferred rule, meaning that the scheduler will still be able to schedule your pod even if the rules cannot be met. So with a node selector, if a node doesn't have your label, it will never get scheduled. Whereas with affinity and anti-affinity, you can create a different type of rule where you set a preference. So you will prefer nodes with a specific label. But if there's no node with that label schedulable, it will still get scheduled on another node. You can create rules that take other pod labels into account. So affinity also exists not only for node affinity, but also for pod affinity. For example, you can create a rule that makes sure 2 different pods will never be on the same node. Kubernetes can do node affinity and pod affinity anti-affinity. Node affinity is similar to the node selector, and pod affinity anti-affinity allows you to create rules how pods should be scheduled, taking into account other running pods. Affinity anti-affinity is a mechanism only relevant during scheduling. Once a pod is running, it will need to be recreated to apply the rules again. Don't expect that if there is a new node with a label and it's a better match, that Kubernetes will automatically reschedule your pod. You will have to terminate your pod first, and it needs to be recreated to make sure if you want to have your pod scheduled on another node. I will first cover node affinity and will then cover pod affinity anti-affinity. There are currently 2 types you can use for node affinity. The required during schedule, ignored during execution, and the preferred during schedule, ignored during execution. The first one sets a hard requirement, like the node selector. The rules must be met before the pod can be scheduled. The second type will try to enforce the rule, but it will not guarantee it. Even if the rule is not met, the pod can still be scheduled. It's a soft requirement. It's a preference in this case. So here's an example that I will use in the next demo. So in your deployment specification, you can define affinity, then node affinity, and here you can define the required during schedule, ignored during execution, and also the preferred during schedule, ignored during execution. So you can combine both. In this example, we're going to look for nodes that match the expression env in dev. So the environment env needs to be dev before this pod can be scheduled on that node, because we have the required during schedule, ignored during execution, and not the preferred. If the label env is dev on one of our nodes, then we can be sure it will be scheduled, because we have a preferred rule, a second rule, and the preferred rule is a preference. So it will look for nodes that match, but if it doesn't match, it will still get scheduled. We're going to give it a weight, and I will explain the weight in the next slide. And then we have the preference. And the preference is match expression, team in engineering project 1. So we're looking for the label team equals engineering project 1. But if there are no nodes with engineering project 1 as a label, then we'll still schedule it on a node that has env equals dev, but is missing this label. So I'll show you how that works in the next demo. Now, in the previous slide, I also supplied a weighting to the preferred during scheduling, ignored during execution statement. So here it is again, weight is 1. The higher this weighting, the more weight is given to that rule. When scheduling, Kubernetes will score every node by summarizing the weightings per node. For example, if you have 2 different rules, preferred rules that is, with weights 1 and 5. If both rules match, the node will have a score of 6. So in this case, we have one node where both rules match, but we're probably going to have other nodes. So let's say that we have another node, and on this other node, if only the rule with weight 1 matches, then the score will only be 1. So then we have one node with score 6 and one node with score 1. The node that has the highest total score, that's where the pod will be scheduled on. So in this example, our pod would be scheduled on the node that has a score of 6. In addition to the labels that you can add yourself to the nodes, there are pre-populated labels that you can use as well. For example, if you want to know the host name, you can use the label with the key kubernetes.io/hostname. So this will reply the host name, and you can use that in your Affinity rules. You also have the zone, and this can actually change once this becomes stable. So you would have to double check your node labels to see what labels that you have. I will also show you that in the demo. The zone is cloud dependent. If you're on AWS, then the zone can be EU West 1A, for example. The region, also cloud dependent, can be EU West 1, can be US East, US West, and so on. The instance type, for example, T2 Micro, the operating system, and the architecture. So depending where you deploy, these can all have different values. But nevertheless, these are labels that you might want to use for your decision making.